Hey, you watching? I'm here to present my project. It's a Hopfield Neural Network. It's a project in my master degree in electronic engineering in the robotics area. Here is the title of my project. I have here the report that it's explaining everything about the project from the theoretical part to the implementation that explains everything. For example, the MATLAB GUI graphical user interface that I use because it's much simpler and it has a better looking. And here I explain how I create the layout, how I create the projects, everything. Basically, almost 99% of the code it's explained here, and the ones that it's not, it's because it's really easy to understand. Here I'm still talking about the code. Here I have the final layout explaining everything. Basically I divide the layout in 9 segments and I explain every segment what it's their purpose in the project. Here I have some testing with the results and the conclusions, and here I talk about the limitation that it's basically the number of patterns that we can teach to the neural network without compromising his performance. The conclusions, the acknowledgement that it's basically my teacher that she proposed us to do this project. At the beginning I didn't know what it was about, but when I started I always saw that it's something that I really like. So I have her to thank for this. Now I'm going to show you guys the project working. Like I said before, I did in MATLAB using the graphical user interface. Here's the layout. First, I'll explain here what everything does. This is the input image. Basically, when I load an image, it will appear here. Here, it's when I add some noise to the image. The image with noise will appear here. And when I try to solve this image with noise, when I use my neural network to solve this image to a pattern learned before, the result will be here. Here it's a text box. Use it to give feedback to the user about what is happening. For example, when I load an image, it tells me image loaded. When it finish running, it tells me to finish. Those things. Here, this part, I use it more for debugging purpose because it was an input to tell how many neurons I want to trigger. So I could basically see how the energy of the pattern is evolving, if it's conversion to a minimal state energy or not. Here I have the buttons that allows me to load the image, to teach the image. Here is to load image from a folder. It loads every image in that folder. Here it's to add the noise to the image. The level of noise it's chosen by this bar, when here it's 0 and here is 100%. And here it's the button to run the neural network on the image with the noise. I have here too a sliding bar that presents me the energy before the beginning. When I add the noise to the image, first it calculates the energy of that image and then the energy after running the neural network. In a good case, the energy should decrease because, as I talk about in the project, explaining in the theoretical part, our our pattern tends to converge from a high state energy to a minimum state energy that it's more stable. So for the Hopfield networks to be working in the right way, the pattern energy should go to an attractor. We'll try to see if that will happen in the project. Now we'll see the project running. First, I load the image here, and like I told you before, the image appear here, and if I want to teach this image to my neural network, I have to press this button and it tells me in the text box new image learning. To teach another image, it's just doing the same thing. If I press this button, it would teach all the image in that folder to the neural network. Now we want to add the noise to one of the three images that we teach to the neural network. I'll choose the 4, and I have the noise like 40%. And if I run, you can see that it solved the image. And one thing that we were talking before, it's the energy in the star. The energy is 100,000, and at the end it's 162,000, almost 163. We can see that the energy is decreasing because it's minus 100. So the bigger the number, the lower is the energy. Now we can choose to add more noise. Now let's choose this one. And if we run, again, it solves the pattern to a pattern previously learned, and again we can see that the energy level is decreasing. This tells us that our neural network it's taking our pattern from a higher energy to an attractor that it says minimal state energy, so that means that it's working fine. If we put the noise in 100%, and I choose this one, you can still solve it. One thing that I was able to conclude is that the more the noise, and it makes sense because the more the noise, the higher is the energy, because it makes sense because the more the noise, the how do you say that word? The more far from from our goal that it's the pattern that we taught our network. So with less noise it would be closer, so the energy will have to be lower. So this is it, the presentation of the project. Thank you for watching it. And again, I wanted to thank my professor for giving me this project, that I really enjoy doing it. So have a good day.